Cluster manager has 4 nodes to start the executors. Based on the data locality principle, the cluster manager will look at the nodes where the data is present or the nodes which are closer to the data, and it will start the executors in those nodes. In this case, node A and node C are the nodes where we have our data blocks, and the cluster manager will be starting the executors in node A and node C. Hi everyone. In this session, we are going to discuss about Apache Spark architecture. We already know that Spark is a distributed processing engine with all the components working collaboratively on a cluster of machines. This session helps you understand how the components of Spark distributed architecture work together and how the communication happens between them. Let's start by looking into each of the individual components and how they fit into the architecture. We will be running any Spark application by submitting the jar or application from the client machine, and the application will be sent to the Spark master. And in the Spark master, there will be a process that gets started called driver program, which is our Spark driver. For every job that is submitted, there will be one driver program that gets started. And the driver program will be the main point of contact for the complete job execution. And inside the driver program, the Spark session gets initiated. And as a part of initiating the Spark session, the Spark driver plays multiple roles. Like it communicates with the cluster manager and requests resources like CPU, RAM, and storage from the cluster manager for the executors. It transforms all the Spark operations into DAG computations and schedules them and distributes the computations in the form of tasks to the executors. Let us see what happens after the driver request for CPU, RAM, and storage with the cluster manager. Let us assume that we have 4 nodes in our cluster: node A, node B, node C, and node D. And we are operating on 10 GB of data, which is split into 2 blocks, B1 and B2. And this block split is just for our assumption to understand this picture. And let us say this block B1 is available in the node A and block B2 it is available in node C. So the cluster manager has 4 nodes to start the executors. Based on the data locality principle, the cluster manager will look at the nodes where the data is present or the nodes which are closer to the data, and it will start the executors in those nodes. In this case, node A and node C are the nodes where we have our data blocks, and the cluster manager will be starting the executors in node A and node C. All of this happens based on the data locality principle. Once the Spark executors are started in the nodes, the Spark executors will be directly communicating with the Spark driver program. Now coming back to the Spark session, from Spark 2.0, Spark session became unified entry point for all the Spark operations. In older versions of Spark, we had multiple entry points for various operations. Like we had Spark context, SQL context, Hive context, streaming context, Spark conf. So in from Spark 2.0, all these are replaced with single entry point, which is Spark session. Even though we say that all these are replaced with Spark session, we can still use these individual contexts and their respective methods. In this way, the Spark community has maintained the backward compatibility in Spark. That is, the older Spark code, which is Spark 1.x code, using the Spark context would still work in newer versions of Spark. In standalone application, you can create Spark session using one of the high-level APIs in the programming language of your choice. In Spark Shell, Spark session is created for you and you can access it via global variable Spark or SC. Now coming to the cluster manager, this cluster manager will be responsible for managing and allocating resources for the cluster of nodes where our Spark application runs. Spark supports own standalone cluster manager or AN or Mesos or Kubernetes. And now finally the executors. So the executors will be running in the worker nodes, and the executors will communicate with the driver program, and the executors are responsible for executing the tasks on the worker nodes. So this is going to be the complete architecture of Spark, which contains the Spark application, Spark driver, Spark session, a cluster manager, and the worker nodes and Spark executors running inside the worker nodes. Now let us see what happens if something in this architecture fails. The first failure would be the Spark executor failure. What if this executor fails? Let us assume that there are two tasks T1 and T2 running in this executor. If the executor is failed, both of these tasks will get killed and the Spark will launch a new executor. These tasks will be recomputed from the beginning in this new executor. The other scenario is that what if the entire node is failed? If the entire node is failed, so we have block B1 which is present in this node. The data that is in this node will also be lost and the entire job gets killed if the replication of this block B1 is not available. So to avoid this situation, Spark will replicate the data in memory. Let this be the memory block and Spark will replicate this data in memory before it gets failed. Like as soon as the Spark job starts, it will replicate the data. Spark master. So this is our Spark master and the master will be available of where the replica is available. It has the metadata for all the data that is present in Spark memory. So master will start a new executor in memory and it recomputes the data. All of this will be happening in the background and developer will not be aware that all this is happening. Now what if the Spark driver is failed? So if the Spark driver is failed, there are two scenarios. If the Spark is running in local mode, there is an option while we are submitting the Spark application called supervise. If this parameter is set, if we provide this parameter while we are running our Spark application, it will launch the new driver as soon as the driver is failed and the executors will start the execution from the beginning. In the AND mode, when we are running it in an AND cluster, so AND has a config file which is mapped site.xml and there will be a parameter in this file which is mapreduce. So based on this parameter, Ann will take care or Ann will handle the driver restarts. Now what if the entire master node is failed? In Spark, we have two master nodes. One is the active master node, the other one is the passive master node. At any given point in time, both active and passive master nodes will be receiving the heartbeat signals from the Spark executors. Both active and passive masters will be in sync. So whatever metadata that is present in master, I mean active master, will also be present in the passive master. As soon as the active master is failed, passive master will become the new active master. Who is going to manage this active and passive master? There will be a service running in Spark called Zookeeper. If you know Hadoop already, you might have heard about this term Zookeeper. So this Zookeeper will be taking care of the new master. The Zookeeper will be aware of the active and passive masters that are present in application. And once the active master is failed, so it will tell that passive is going to become our new active master. So this way, Zookeeper will help the entire application to get backed up once the active master is failed. Now there is one more scenario. What if the Zookeeper itself is failed? Generally, the Zookeeper will be following leader and follower architecture. It means that if there are two nodes which are acting as Zookeeper, so one will be leader and the other one will be follower. If there is a Zookeeper failure, which means that if the leader fails, the follower will become the new leader. Any good system will have more than two or three nodes acting as Zookeeper. So when there is a leader failure, follower will take the role of the leader. So this way, Spark will handle the failure scenarios. And that's it about architecture of Spark and failure scenarios in Spark. See you in the coming session.